I'm going to go through all the problems on the review sheet one by one. Most of this, well, that's about half and half in terms of calculator and non-calculator. There's really no particular order. They are not in order of the test or of the calculator versus non-calculator part. This graphing part is on the non-calculator for sure. The directions are all up there. Make sure you answer all the questions. So our x-intercepts, setting each factor equal to 0, are x equals 0. Ignore that negative until the end here. We get -2, +1, and -4. Now, with the multiplicity, 0 doesn't have any. -2 is going to slide. 1 we don't have to mention, and -4 is going to bounce. So I'm going to put these on the graph. The y-intercept, so we plug 0 in for x, so we would have -0, and then we'd have 2 to the third, -1, and 4 squared. Well, none of this matters because we're multiplying by 0, so the y-intercept is at 0, 0. And behavior. Now we want to pay attention to that little negative sign. So we have -x times x to the third times x squared. So this is -x to the 7th. So the end behavior, and you're asked specifically to write it out. X goes to infinity, x goes to -infinity. On the test itself, it'll be better spelled out. Like you'll have blanks for all these things, because I know it's hard to remember to answer all these questions. Including you'll have a blank for the y-intercept as well. So then this means that y would go to -infinity, right? Because the ends are going to look like this, down and then up over here. And so if x goes to -infinity, y will go to +infinity. It looks like we've answered all the questions, and now we need to draw the graph. So we know that this end is going to go down, this end is going to go up. It's going to bounce here at -4. We don't know how high. If you notice, the directions say no additional points. And then when you come through here, it's going to slide. And then it turns around and goes back. We don't know how high. And it just goes down from there. It's a rough graph, but that's the idea of it. For number 2, it's just a theoretical question. We have a 4th degree polynomial, and we have these coefficients. With real coefficients rather, and we have the roots. This would be x plus 3, would be a factor, then we'd have x minus 1 plus 2i. I know we haven't done this, but you know the ideas for the complex, 1 minus 2i. You know that complex roots come in conjugate pairs. We have no way of knowing what this 4th root would be, so the answer is no. We don't have enough information to find the 4th root, since both complex numbers are already there. So both complex numbers are given. Normally we could go, oh, we'll just do the conjugate and we could find the other number, but we can't do that here. For this, of course, we're going to set this equal to 0, so 3x to the third minus 11x squared minus 4x equals 0. Factor out what they have in common. And we're trying to get to 11, which is a lot bigger than the 4. So I'm going to put the 4 and the 3 so that I can multiply them together. That'll give me 12. -12 plus 1 will give me -11. So we get x equals 0, x equals -1/3, and of course x equals 4. These go on the number line. You cannot use 0 because 0 is on the number line. So I'm going to go with x equals 1. Plugging that back into the original, we would end up with 3 minus 11 is greater than or equal to 4. So -8 is greater than or equal to 4. That's a no. All right, so this section does not work. These are solid circles, and so the answers go no, yes, no, yes. So the interval notation on this, -1/3 to 0, union 4 to infinity. For number 4, we'll set it equal to 0 and put it in standard form all at the same time. 2x to the third minus 3x squared minus 32x plus 48, set that equal to 0. They have an x squared in common, leaves you with 2x minus 3. These have a -16 in common, also leaving you with 2x minus 3. 2x minus 3 is the common factor, and x squared minus 16 is the second factor. So here we get x equals 3 over 2. And when you take the square root, I'm thinking 4, x squared equals 16. So then x would equal plus or minus 4. We'll put all this on the number line. In order, of course, -4, 3 over 2, positive 4. All these are open circles because there's no line under it. And then we'll pick a test area. I'm going to go with x equals 0, which of course is right here on the number line. And when you plug 0 back in, you get 0 plus 48 is less than 0 plus 0. So 48 is less than 0, which is of course not true. So that doesn't work. So the areas or the sections on either side do. And we have the answer of -infinity to -4, union 3/2 to 4. This one says x-intercepts, which is real zeros only. So if we get imaginaries, or if you can tell it's an imaginary answer, you do not have to provide that answer. So we have 4 terms, so we're going to group this up. So this is x squared in common here. This is x plus 5 left. The second 2 have a -9 in common, leaving x plus 5. So then the x plus 5 is in common, that comes out. And then we're going to have x squared minus 9 left. So we get x equals -5, x squared equals +9. So no imaginaries here. So x equals plus or minus 3 and -5. So we happen to get all 3 real answers. Make sure you know this pattern, the sum or difference of 2 cubes. So remember, we start with the cube root of the front and the cube root of the back. I guess there's only 2 terms, so the first and second term. So this will be x, and this is a 5. Then the pattern goes square the first term, multiply them together, square the second term, and the signs are same, opposite, always positive. So here we know we get x equals -5. What happens in this second part is you know that this is never factorable and would require the quadratic formula. More importantly, you know what this graph looks like. This is the cube root graph, moved up 125. So this is straight up parent function moved up. So you know it only crosses that x-axis once. So these other 2 are imaginary. So no sense in wasting your time trying to figure it out. We have only one real answer here, at x equals -5. Now the directions change. And here we're going to find all of the zeros. So all means all. Negatives, imaginaries, anything we can come up with. Again, we have some grouping because there's 4 terms. First 2 have x squared in common, leaving you with 4x minus 1. The second 2 have a 9 in common, leaving you again, that's a +9, with 4x minus 1. So now we have 4x minus 1, and the second quantity is x squared plus 9. So here we get 4x equals 1, so x is 1/4. And here we get x squared equals -9, and we are going to have some imaginaries, but it's okay because of the directions, plus or minus 3i. So we get all 3 answers. You can tell by the degree. All means the degree should match the number of answers. Reals, sometimes it won't. And then for the second one, Greatest common factor, please make sure you're checking for that. A lot of times if your front term has a number or if your end term has a variable, there's probably a greatest common factor somewhere. This is, of course, x squared. So we're left with x squared minus 3x minus 28. Set that equal to 0. Don't lose that x squared. Two numbers, when we multiply, we get 28 and subtract them to get 3. So we're looking at 7 and 4, with the 7 being negative. This is a double root. It doesn't really matter because we're not graphing it, but it does count for 2 answers. So there's 2 answers. Here we get x equals 7 and x equals negative 4. So we do, in fact, have all 4 answers. They're just not 4 different answers. Which kind of leads to this next problem. If we have 6 degrees, or a degree of 6, and 1 0 happens twice, so not too awfully different than the one above here. I know it was a 4th degree, but this was a 4th degree in number 8, so I'm looking at number 8. Number 8 was a 4th degree, but we got 3 answers because this one happened twice. So if we think about a 6th degree, and one has a multiplicity of 2, then we can only get 5 different zeros, because one will happen twice. So there could be at the most, 5 different numbers. Now for number 10, you'll have to put this one in the calculator and come up with some values. And when you put that in the calculator, go to the table. You could go to the graph. Just be careful with that, with the decimal answers. Sometimes they're not super good. But I do think this graph looks okay. And you get x equals 1 and negative 3. So if you do look at the graph, just double check it with the table real quick. And make sure, of course, that you're looking for where y is 0. And so you'll see we get 2 values. Now we're going to use synthetic division. So we're done with the calculator. Move on to synthetic division. Doesn't matter which one you start with. I'm going to start with 1 because I feel like it might be easier. Make sure you have them all. X to the 4th, x to the 3rd, x squared, plain x, and of course the plain number. We do have them all. So no zeros. Bring the first one down and then multiply. Always add when you're in through here. So that's a 3. Multiply again. Add again. 1 times 4 is 4. Add them up, we get 12. And then we have a 12 here, and that's a 0. So that's exactly what's supposed to happen. Do not start over. Keep going. Now we're going to use the negative 3. Bring the 1 down. Multiply, we get negative 3. We're adding in here. This is a 0. That's a 4. Negative 3 times 4 is negative 12. And so it does work. Putting the powers back on, this started as x to the 4th. And then we divided, so it became x to the 3rd, and so now we're at x squared. So the polynomial that we have left is x squared. There's your x term. That's a positive 4, so x squared plus 4 equals 0. So we know that x squared equals negative 4, and so the answers here are positive and negative because we took the square root, 2i, and then of course don't forget the ones that you got from the calculator when listing your answers. Now, as you know, these take a minute, so it's definitely going to be on the test. It won't be on here twice, but it's definitely on the test. So get yourself set up. We're supposed to have a degree 3, which means we should have 3 zeros. Of course, with this, they don't give you the third one. If 2i is a root, then negative 2i is also a root. So our factors are x plus 1, x minus 2i, and x plus 2i. And the thing with imaginaries is you really should multiply those together first. So the x plus 1 is just going to hang out there for a minute. Then we're going to have x squared. Now we just did this. We already know, right? That's the answers. So we already know this is what it's going to be. But we'll go through it just to make sure there's something like this on the test and it doesn't match. So I want to go back through it. So we get x squared minus 2ix plus 2ix. Then the last terms, negative and a positive, make that a negative 4. I times I is I squared. I squared is equal to negative 1. So this comes out and we put in the negative 1. That's what creates the plus 4. So now we have x plus 1, these are gone, times x squared, negative 4 times negative 1 is a positive 4. Now we multiply this. I'm going to just go through this carefully to make sure I put it in the correct order as well, keeping it to one more step. So x to the third, then we have x squared, then plus 4x, and then plus 4. So that is in standard form, no like terms, it is finished. Now for this, if we know that x equals 0, that is just a plain x. Then we have x minus 1, x plus 2, and x minus 3. You can do what you want, multiply. I'm just pick 2 and multiply them together. I'm just going to split this up right here and multiply these two things together, so we get x squared minus x. And then I'm going to multiply these two things together. Now work smart. This will give you x squared. You know you're going to add the negative 3 and a 2 in the middle, so that's a negative x. And then you're going to multiply the negative 3 and the 2 at the end, so that's a negative 6. Now, unfortunately, of course, we're going to just have to go through this one by one. So x to the fourth, and then I'm just going to take x squared times everything. So x to the fourth minus x to the third minus 6x squared. Then I'm going to use the negative x and do the same thing, all three. So then that gives you negative x to the third and then, sorry, I was checking my signs, plus x squared plus 6x. I bet the answer is wrong because everything's kind of messed up here. So now we have x to the fourth. This is hard to keep track of. Minus 2x to the third minus 5x squared plus 6x. Now for this one, you're asked to write the factored form. So don't multiply it out. So every 0 you have will create a factor, and it looks like we have lots of them. So let's start with the negative 6. So I'm going to start here, just randomly start at the left. That factor turns into x plus 6. Then pay attention to what's happening at that point. It is bouncing off the x-axis, which means it is squared. It technically is any even power, so if you'd like to write to the power of 8, go right ahead. We're not going to multiply this out anyway. It doesn't say we have to have a certain degree, so there's really kind of no rules as long as that's an even power. Then the next root is a negative 3, so that's going to be x plus 3. It slides through there, so that should be an odd power, not 1. So you want to put a power of 5, go for it. Our next is a positive 1, so this is x minus 1. That looks like it just goes straight through. I'm running out of space here. Then we have, I'm just going to keep going right on my picture. Then we have a positive 4, so that's x minus 4, and it bounces there, so that's squared. And then we have one more, x minus 7, and it bounces there, so that's also squared. So we have 1, 2, 3, 4, 5 places where it touches the axis, and we have 1, 2, 3, 4, 5 factors. So this should really be, it should not look like that. I just ran out of space. So it really should be one ginormous list of multiplication. That's really what it is. Please bring all the questions that you have back to class and let me know what else I can do to help you.